Chelsea and I just got back from our week-long trip to the other side of the world. We flew to Lake Como, Italy to attend our friend's wedding and took the opportunity to fly a Skyhawk on floats in this beautiful location. All of that is covered in the previous video right here on Aviation 101. We're back in Torrance, California now to roll up our sleeves and dive back into building our Sling TSi at the airplane factory, which is the headquarters of Sling Aircraft North America. In the previous build video, we ended week 3 by moving to the fuselage hangar to hang our brand new Rotax 916 IS onto the front of the airplane. And now with that beautiful motor hung on the motor mounts, we're tackling a lot of firewall forward tasks for the next 2 weeks. Week 1 was very much about the wings, ailerons, flaps, and everything, wingtips. And then week 2, we dove into the empennage and we ended up pretty much finishing the empennage. We have a couple more things that we're just waiting to get in, like little lighting accessories and stuff like that. But all of that's pretty much done. We've got all the camera mounts sorted out, camera power supplies are sorted out. And in week 3, Chelsea and I ended up splitting up to different tasks. She ended up coming over here, started working on some firewall forward preparation for the engine to get hung, while I finished up on the empennage with Bill. And then the Friday of the last week that we were here, which was the end of week 3, Chelsea and I were both in here in the fuselage hangar working on firewall forward prep. And at the very end of that day, we hung the Rotax 916 IS onto the front of our Sling TSi right here. Today, we're getting a little bit of a later start. It's 10:35 in the morning here at the Build Assist Center and Sling Pilot Academy here in Torrance, California. And we have some firewall forward stuff to do. But I think before we dive into that, I am going to start at least separating and organizing a bunch of parts here that are laid out on the table for our little T-bar rudder pedals. Much more coming on what we're gonna be doing and stories and all that kind of stuff coming out. But that is what's on our agenda today. Okay, right there. We need to make sure there's 12 of those guys. Those are the T-pedals, okay. So that kind of goes like that. That's why it's offset.
Definitely a yoga position.
That wasn't the rivet, that was my back. Putting together the rudder pedal assemblies down here. I just put in the bushings, so before everything gets riveted together, these big bars need to go in. This is basically like the meat and potatoes of the rudder controls. So these are just push-pull tubes basically, and you can see in the middle, maybe from that angle, this is where the cables connect that are actually going to be the linkages that control the rudder as well as the steerable nose wheels. So these are the left rudder pedals and these are the right rudder pedals, so they will do that. And you can see those little arms are going to be pushing and pulling the cables back and forth. And we don't have toe brakes on this airplane, which actually makes it a lot simpler down here. We're just going to have a single hydraulic handbrake right here with a hydraulic parking brake valve, which actually I really like that design. So now I have to put the other set of bushings on top of those things, Cleco the little plates in place. It's all going to hold it until I can match drill, pull some rivets into there, and then it'll all be together. Those things will be freely moving and secured in place. Okay, week 4, day 2 here at the airplane factory in Torrance, California, right across the taxiway from Sling Pilot Academy. Don't forget that you can use code AVIATION101, the referral code, on your enrollment form or scholarship application if you want to consider becoming a pilot as a career move. You can do it right here at Sling Pilot Academy and get $1,000 off your full-time pilot training course, either the 6-month course if you're coming in with your private already done, or the 9-month course if you are starting with 0 flight time. Referral code AVIATION101 on your enrollment form or scholarship application gets you that $1,000 off. Link is down in the description. Yesterday was, I would say, very homogeneous. Kind of boring. One task that I worked on all day, and that was the rudder pedals inside the airplane. The T pedals are in, and it actually looks like rudder pedals. So anyways, worked on that yesterday, and then I moved on to firewall forward section of the airplane, so on the firewall between the firewall and the engine. Ended the day with just pulling a couple rivets on the firewall to finish up a couple just super simple brackets. And what I'm about to work on now is the brake fluid reservoir, which is a little vial. There's actually one on the corner of that TSi's firewall there. We've been told that that one is complete and it's already been inspected, everything's good to go on it. So if we need to use that one as a visual example to back up the build manual, if we just need a little reference as to how something goes together, we can glance at that. I just confirmed the way this came out of the package is actually reversed. I'm gonna take this bracket off and flip it over. I need to take the bracket off anyways to pull the rivets. So just gonna take out this Allen screw, and there's a washer right there, and then this will get flipped over. All right, what I'm gonna try and tackle next is this oil reservoir, which is gonna go on the firewall. The brackets are already mounted. We just have to make sure we cap all of these, and this is gonna get torqued and safety wired right here. And then this will go on, and then that'll be super simple. All right, this is the oil reservoir.
Okay, so we need to, I'll just actually leave these on here. So even when it's installed, we can see this. Because these O-rings have to go here for the connectors to make it more weatherproof. There's a lot of brain activity that's gonna happen right here. I think that's good. I don't want it to be.
All right, so this is one of the regulators from the fuse box right here. Had to remove it from the fuse box and stand it off a little bit according to the instructions with these Adele clamps and spacers and everything, so that it is not rubbing on the motor mount right here. The other one is still attached. There's two regulators. They're independent on the engine control unit, the ECU or the EMS, is what Rotax calls it, but these are all snugged down. There's the grounding wire right there. Might put like a little tiny, if we can, if there's room, put a little tiny zip tie mount right here and just tuck this wire right here and just put a little zip tie so that it's not making a hard bend, and then that keeps it nice and clear of the motor mount. Not touching the motor mount anywhere. So that's perfect, that's grounded. Good.
Are you making airplane noises?
I am. Feels good. The rudder pedals I put together yesterday.
Josh, he's rolling this to the curvature of the plane.
Oh, that's cool.
Look at that. Wow.
That looks good. This is the intercooler. It cools off the air that comes out of the turbo that's going into the intake so that the engine can run more efficiently and it's not breathing in all this inefficient hot air straight from the turbo. So it's all wrapped in saran wrap, a very liberal amount of it. We may go ahead and tape some cardboard over both sides so that the fins don't get damaged just from handling it. There are plugs on the inlet and outlet here, and that is where the hoses that Chelsea just modified and cut are gonna go. So one of them is gonna come out of the turbo, which is, let me get my orientation. Let me just show you over here. Intercooler is gonna mount right about here.
So I just got done taping some precautionary cardboard to protect the fins of this intercooler, and Josh just cut the hose.
Yeah, so here's the throttle body. You can see the valve moving in there. And then this is the intake regulator. It's got a bunch of sensors here, like O2 and all that kind of stuff. Anyways, this piece of hose needed to get cut such that this guy will come out about perpendicular to the ground as the airplane's sitting. So I cut the hose, it was already marked, and I just verified that it was right. So that will slip on there, kind of get it right. And then a hose clamp will go right there, and then the regulator gets squeezed into this guy right here. And then once that's in, then this guy will come off. I'll take it off here in a second. This plug on the hose there. That's where the intake from the intercooler comes and rounds that corner and goes into the regulator there. And then, like we said before, the hot air, not exhaust, the exhaust is coming out right here, and that's gonna go out the exhaust pipe. This is hot air coming out of the turbocharger that's highly, highly compressed, way more compressed, way higher pressure than the ambient air. That's why this engine will perform so great at high altitude. Because it got compressed, that air is now super hot. it can go into the engine and the engine will burn that air with the fuel mixture, but hot air, just like on a high density altitude day, is not gonna perform very well in the engine. So the point of an intercooler is it takes ram air through a scoop, like a little, like a bazooka scoop. You can see there's the big opening on that cowling over there for it. That's pushing air across the intercooler, and as that hot air comes through the intercooler and all the fins, that ram air cools it off, and by the time it comes out, goes into the regulator throttle body and into the intake manifold, it's way, way cooler, which is gonna make the engine run even better. Even though it already has a turbocharger, the intercooler is gonna make it run even more efficiently after that. Okay, I'm gonna put that back on right there and leave it. We're cleaning up. We've got all of our firewall forward stuff kind of condensed on the table here with the manual sitting in front of it, but made a little bit of progress on the firewall forward today. So I installed the brake fluid overflow reservoir. Chelsea mounted the fuse box for the Rotax 916 onto the firewall. I mounted regulator B next to that. It's clamped with the Dell clamps onto the motor mount. After that, I installed the oil reservoir that goes on the firewall. That's on the pilot side. And then after that, we cut the inlet and outlet hoses for the intercooler. But we're calling it quits on week 4. I gotta remember all this stuff, all these numbers. Week 4, day 2.
Week 5, day 1. It's Monday morning. We are just now pulling up to the build center here in Torrance, California. It is another beautiful sunny day here in California. We have the maintenance doors on both sides are open. They're doing 100-hour and inspections on a lot of the Sling Pilot Academy Sling 2 light sport aircraft here. And then here's our build center hangars open and everyone is busy at work. So I'm gonna be working in the hangar that we've been in for the last 2 weeks. I'm gonna start getting out some build manuals and reorient myself. Last week was a short week and I don't feel like we made too much progress, but we have a full week this week and I'm gonna be working with a gentleman from Ukraine. His name's Sergey. They call him the bear for some reason. I don't know what the backstory is on that, but he is already fabricating the control sticks. Let's go over here and see real quick before Josh heads over to the other side. So you can see that there is a Sling fuselage. They have the empennage, the tail section, and 2 wings out on the ramp out here, which is what we're gonna be doing with the Sling TSi right before we leave. It's where all of the parts will come together for the first time. So we've hung the engine, that's on permanently. And then we will take the wings and the tail or the empennage section and we will do a trial fit of everything, which is what they're out here doing today on this aircraft. You can see that they've already done all of the fiberglass work on this plane. The cowling has already been fit. There are 2 types of additional generators or alternators that you can add on to these aircraft. One of them you have to do a cowling modification on. We did not go with that one. But they have some really good fiberglass guys that are working in the shop that are doing all the composite, all of the modifications, and even fabricating new parts from scratch, which is like so incredible, the capability and the talent that they have here in this build center. But at some point today, we will see these wings come together and meet onto this fuselage, and then that's when they are gonna make sure that everything aligns and goes together properly, that all of the stuff is gonna hook up really well. They're gonna do like a fit and trim just like we did on the winglets that come off the Sling wings here. So they're gonna do that here today, and then we're gonna be not far behind them. So I'm gonna look for Sergey. Josh is headed over to work with Bill.
Sticks.
And when I find him, we're gonna continue working on these. So this is actually ours. I know he said not to touch 2 areas, but here are the control sticks. So just like the engine, the Rotax engine came brand new from a factory. I'm gonna grab this trash. So just like all of that stuff has already been done and built, as an inspector, my eyes are still always combing through every single last thing, not just assuming. I know that they have good quality control, but you can never have enough. So my eyes are just going over everything, making sure that there weren't, a rivet that got in the wrong batch, which is something that we actually did when we were in the wings hangar. Is there were some rivets that were mixed into the bin, and we had to, be really diligent. But while we were going really fast, I pulled some of the rivets that were too short. And so whenever I went back and inspected, I had to drill them out. Just little things like that. It doesn't matter if it's your work, you want to work as a mechanic, leave, put your inspector hat on, go take a little snack break and come back, and then now you're an inspector. So you want to kind of bounce between that stuff. Or in a situation like this where you have, more than one person, more than one expert, even if they're not necessarily an A&P or an IA or an aircraft builder, just getting a second set of eyes on everything goes a really long way.
All right, I just finished getting everything uploading for this new Cockpit Club series that I just released. It's a VR private pilot series that goes through the whole private pilot syllabus from a 360 perspective in the pilot seat. So they're full-length flights. It's like 60 hours of flying content. Anyways, that's on Cockpit Club. I just got it uploading here. I'm going to grab this Ziploc bag, and we're gonna go to the hangar next door to work with Bill. So these are the camera mounts and power supplies, and we're gonna get these finished up on the wings, and then at that point, the wings will be done and ready for paint. That airplane that Carlos is masking right now is the one that he gave us the rendering for.
You wanna go peek in there?
I would like to. He's already got some of the blue on it.
Let's go look.
Let's see what kind of blue that is. Mr. Carlos. Hello. How you doing? Very cool. And did you already paint the, the wings already painted?
The wings empennage, and the only thing that I need to paint is the top, cowlings and doors.
Beautiful.
That's the blue.
Yeah.
And then after that, I cap it again and then shoot the last coat of clear.
Okay. Very cool.
And they tail little things.
We're working with Evoke right now. We're going back and forth with them. Very cool.
That's cool.
The blue is beautiful.
Yeah, this blue is for Ford.
From Ford?
Lightning Ford, that's the name of this.
Okay.
Color.
We're sampling colors.
Oh yeah, you get a better picture in the sun.
Yeah. That metallic looks beautiful. Yeah, definitely, depending on the angle, looks like way brighter or darker. Yeah, that looks great. I like that color a lot. But we'll find one that we both like. Rivets on the ground mean walking backwards. Yeah. Bill's gonna clean up real quick, and we're gonna scoot these wings that he's working on over a little bit and pull ours in. So this is the 3D printed power supply housing that's gonna go inside the wing. These are dual USB-C ports. I believe they are 45 watts a piece. They take in 12 or 24 volts here. And I put a nice sheet of rubber on the bottom that's gonna very nicely pad it. So when these are fastened to the inside of the wings with probably M4 screws is how big they'll be, there's not gonna be any chance that it's gonna score the aluminum just sitting there chattering. This material is PETG infused with carbon fiber. So coming out of the 3D printer, this is a solid part. It doesn't have a honeycomb or a grid structure inside. It's solid. Makes it a little bit heavier, but it is really, really stout, really, really strong. Here's the two mounting points for the cameras with the doublers. This is where the USB port's gonna go, which is this little bulkhead connector. This is going to go inside the wing right in here. It's totally away from controls, totally away from everything else. And we're basically just gonna have 4 screws holding it in. It might even be down here, just wherever is gonna be the most out of the way. We're just gonna look at travel of the controls and everything, where we can secure cables, where we can get the most slack from everything. And basically it's gonna go like, maybe right there, maybe up here, we'll just figure it out, but it's gonna go inside the wing, just like that. Technology will change at some point, and in the course of owning this airplane, if these fail, if we ever wanna replace it with a different solution, something like that, that's why we want this so close to an inspection panel, because we can get right in here and swap. We could even swap the whole housing if we want. This is custom made, it's 3D printed. I designed this in CAD, Jonathan here printed it in the printer. The bore of this housing, where this little barrel connector is in here, it's a standard size, so you can get other USB accessories if this ends up having RF interference or something like that. We can take this inspection panel off, get right in here, replace it, unhook it. We're gonna have blade connectors that connect this guy right to this. This is gonna be USB-C from here, and it's basically just gonna do that and go through the wing at that point. So it's gonna be super, super easy to maintain, super easy to get in here and replace if we ever need to. Easy maintenance is the name of the game, so that's what we're going for here. So that's what we're gonna work on with Bill, get these holes drilled and everything fitted, and I think the wings will be ready for paint. at that point. Okay, so this is what it's gonna look like on the inside of the wing. We decided, this was Bill's idea, to put it right about here. And I think that's gonna work out really nicely. That way, when we go inside the inspection panel, that will be super easy to get to the connections if we ever have to replace it. Nice.
Okay, let me go.
Release.
Okay.
Sweet.
So,
And then here's the level,
okay.
provided the wings level.
Yeah.
All right, Bill's gonna go get a deburr tool and he's gonna burr the front and back of these guys, make sure the holes are nice and clean. But there's the 4 holes for the power supply. So this guy will eventually, we'll put it all together. We'll show you exactly what it looks like on the inside of the wing once this is done. Right inside the inspection panel right here is the power supply. Here's the little USB-C port, and then just have 2 Clecos holding 2 of the 4 holes on this power supply. And it is just right inside there. And right here is the bell crank for the ailerons, which is what actually moves the ailerons. This tube comes from right here and terminates right into the bell crank right there. And then there's a tube right here that will go straight up, or aft is what it'll be, to the ailerons. So the stuff that's inside of the inspection panel here for the power supplies will be completely out of the way. No possible way that that can interfere with that stuff. Even if that little pigtail came loose, it's not gonna get in the way. This cabling is gonna be secured down, and then it's gonna terminate right here to those 2 legs. Holes are drilled for the camera power supplies, and with that, I think we're done modifying the wings. They're ready for paint. So I'm gonna take these Clecos out, take the USB port out, run the power cable through the holes once again, and take all the hardware out so that it can go on to paint when it's ready. I think we're done with the wings at this point.
Okay, so here is what we are working on. We are doing the control installation for the sticks that are gonna be mounted. They're center sticks on the left and right. One of the things when you're building that you wanna pay particular attention to is what orientation the fasteners are installed in. And something really important to remember is just because you took it off, that way doesn't mean that it was installed properly to begin with. So while I always encourage taking pictures before you disassemble something, because you might need it to tell a bigger part of the story later, it doesn't always mean that that's the way that it should go back together. So you should always have your reference material out, your IPC, Illustrated Parts Catalog, whatever you're using for your reassembly. One of the things that it says over and over in this build manual is to not only to install the rivets in the orientation that it shows here so that the clearances are proper and you don't have any sort of jamming, especially on a control surface application, but to also make sure that you only install the rivets that are shown in each phase of the drawing, because you might install too many rivets and then you might have another part that needs to marry in on some open rivets later. So crank it along on this Monday morning. You'll typically have one of 3 types of fuel tanks. You'll have either a tank that is built outside of the wing and then it is secured into the wing itself, or you might have a bladder, which is, just like it sounds, like a malleable material, and it fills up and it drains and it's always expanding and contracting. They do wear out and have to get changed from time to time. Or you might have what we now have in the slings, which is considered a wet wing. So the fuel tank is actually built into the wing itself. Everything has to get sealed. When these wings are shipped here to the build center here in California, Bill, he always does a pressure check on them. So that process is getting the wings, inspecting them, and then he puts 1 PSI of pressure into the wing and watches a gauge, and he'll do a leak down check for 1 hour. So 1 hour at 1 PSI, and then he will make sure that he has absolutely no leaks or no leaks suspected in the tanks that are in the wet wings of these slings.
This is a modification. This isn't Josh and Chelsea's, but I did their tanks before they came out here, so they didn't get a chance to roll around on the floor with me and put them back on. And these are ones I took off, and just to make sure that nothing happened during the removal, I'm gonna do a little pressure check. So this is a little handmade thing here. I don't know if this is like maybe a hand bilge pump for boating to get water out of your, I'm not sure what it is, but it was made before I got here. And it's got a little gauge. We're gonna take it up to 1 PSI. They like you to do it for about an hour, but this was already done and it passed the test the first time around, so I'm just gonna put it up to 1 PSI, a little bit beyond, and watch the gauge. As long as the gauge doesn't move, there's no leaks. If the gauge moves, you get your basic dishwashing detergent, some water, maybe a paintbrush, and start checking out everything, because all these fasteners from here down and all your fittings are all sealed. So everything's sealed. You want to brush it, wait for the bubbles, that way you can pinpoint your leak and take it from there. I don't think this should be a problem, but I did notice a couple of dings. This is your fuel tank here. And one of the things you need to watch out for when you're doing one of these and you go to install your tank, always use drill stops when you go to clean your holes out from the outside, because if you do not, people have done it several times, go right into your skin of your tank and you don't know it until it's painted and you're excited and it's got fuel and it's dripping all over the floor and you get to start all over again. So very important, keep that in mind when you're doing this. Use drill stops. I will show you what they look like. You can buy them from specialty tool places, Aircraft Spruce. They come in different sizes for different drills. And we very, very rarely have a problem with tanks leaking from the factory. It has happened a couple of times only. Usually they do a pretty good job of it. Supply return, and I believe that the high wing's different. I believe this might be just a continuous run between the tanks, I think. We've just really kind of done only a few of these things. I haven't really sat down and looked at a lot of it.
And then you can also see right here, here's your fuel sender, right?
Mm-hmm.
So that's where you're actually, it's typically a resistive type device, and it's got a float on it, and it will live in this wing and give off a certain type, certain level of resistance, and it's calibrated so that you have a digital representation and very accurate representation of how much fuel you have in your tanks.
Okay, so now I showed you guys a hand pump. You can do that just fine with a small fuel tank, but it'll take you 10,000 pumps to get this thing pumped up. And what you don't want is having one boob bigger than the other because you're only pumping with one hand. Don't let your friends make fun of you. So what I normally do is your standard Home Depot, Lowe's tire pump. And we've also got our fitting down there for that. And I'll just trigger it. I won't go crazy and just let it go full blast. Get it to where it's gonna work for me. Okay, so we're getting up about 1. And the tank's gonna expand and you'll see the needle drop a little bit. See how it's inflating?
Yeah.
You can see the light in there? So that's good. Take that off, let it sit.
And you can see where it's a little bit puckered around these
around every
rivets.
fastener, yeah. So imagine if you weren't paying attention, try to do 10 pounds, you'd have a big giant grenade on your hands probably. Okay, so it fell a little bit below the 1 because it's expanding and it's hot out, a little hot. So then you can do your...
You can fine tune it with that.
Yeah, exactly. And I go just above the 1 so I definitely know it's falling if it's gonna fall.
Perfect.
Like so. And I'll just watch it for a minute, wait till you see a definite leak source. And when you do, depending on how you make your thing, this is all homemade, like I said, always check your fittings first because that could very well be. I've had leaks around the cork because it's not evenly tightened. Check the obvious stuff first, your fittings right off the bat. If it's not that, start brushing on soap all down these sealed areas. Every place it's sealed, all fasteners, everything.
Out of all of the tanks that you checked, I know that you said that it's not very common that you find leaks, but if you do, and it's not the gear here, where's the most common?
It's usually a fastener. I mean, we've had them forget to put a fastener in and send it off, and we can't understand where the whistling's coming from. So we're really looking, there's an open hole usually under here somewhere where you can't see it, or they just don't seal up a rivet well enough. That's usually the
If
culprit.
they do that, you have to take this sender unit plate off and go in that way and seal it?
No, you can take the rivet out, get another self-sealing. There's self-sealing pop rivets for the tanks. They're not like the ones we've been using on yours. Seal it up, shoot it, and actually there's lightning holes. If you look at the drawing, every rib has a lightning hole all the way down. Get a buddy, shake it down to your filler tank, get a magnet and take the rivet butt out and you're good.
Wow.
Yeah.
It feels tough.
Oh, I know, man. And you'll see when I let the air out, it'll all go relax.
So the part of a wet wing concept that always kind of scared me is, well, what if something goes wrong? It develops a leak, it has corrosion, whatever. You have to literally rip the structure of the wing apart. And it's like, you know, in some cases on older planes, it's more expensive to make the repair than it is to just get a replacement plane of a similar era. What makes me comfortable about this wet wing design is you have a lot of rivets holding the thing in, but if you ever have to remove the fuel tank, it's just a lot of rivets that have to get drilled out. So these are the two main tanks off of that high wing. I got a shot over there a minute ago, but they're sitting right there. Those are the extended range tanks for a high wing. We already have these tanks that are pretty similar, slight differences, but very similar in the TSi. They're already installed. Bill's already leak checked them like he just said. But I like that about this wet wing design. The whole thing can be removed without destroying the structure of or destroying the cosmetics and structure of the wing. This wing right here is where these came off of. So you can see it's this big chunk gone off the leading edge. That's the fuel tank, and the extended range tanks go out here. So don't get me wrong, to remove the tank, it's an undertaking, but I'll take it. For a wet wing design, this is not bad.
Really cool pictures of cars pulled up to try to convince Josh what color we should paint the plane. I'm loving this, but Josh said it looks just like my plane.
For the record, it's baby blue.
Like these colors, and then the accent would be like a burnt orange. Like, I love those colors.
These are the control columns, the control sticks left and right. And here's the build manual. I need to install, let's see, what am I looking at here? These green brackets. I need to install these green brackets, and then I need to install, it's gonna be these gray ones right here with the 4 M4 screws. I need to do that on both sides. And then this piece right here, oops. I need to install this piece right here, which needs to first get riveted. Actually, no, it first needs to get screwed in and then it needs to get riveted in. It'd be very awkward if I riveted it together and then tried to screw it in, because the control column, the aileron and elevator control tubes will need to slide into that guy, and with a big rubber bushing, and that would not be able to happen if I rivet it together first. So first screw it together right here and then rivet it. Then put the pipe in, then rivet it. That's what I'm gonna work on next. All right, it is 3:42, and we've called it a day at the build center. Not a tremendous amount of visual progress today, but the way it was explained to me is when the control columns go in, when I say that, I mean the control sticks, or the joysticks as they're called in the manual. When they go in, they're gonna have to come out and go back in a few times to fit stuff, move some brackets around, move some fasteners around, just to get everything to nicely seat before you actually squeeze rivets and permanently mount it in place. The two items that got accomplished were, I wanted to remove the dovetail mounts for the camera mounts on the wing that we last worked on. So we did that, removed those. That just took literally 60 seconds. And then the other thing that it probably took about an hour, or maybe a little more than an hour, was to drill the holes for the power supplies to be mounted on the wings, on the inside of the wings for the camera mounts. That all came together super nicely. I'm super happy with how all of that came together. And then what Chelsea did with Bill while I was working on that stuff is Bill walked her through the process of pressure testing the fuel tanks. So tomorrow morning will be more of the same, and we're gonna really lean on the guys at the Build Assist Center for guidance on what's next in conjunction with the manual. So we've called it a day, week 5. Day 1, we're heading home to go take Millie on a walk, have some dinner, and call it a night. Okay,
Made it to the build center here, and I am solo today. She's gonna hang out at the house and get some computer work done today while I go be a part of the progress that's gonna be happening today. Allergies hit me really hard this past weekend, so my voice is like, it's hanging on with everything it's got. I'm about to lose my voice, so I'm hoping that's not gonna happen because I have voiceovers to record and obviously talking on camera and all that kind of stuff. It just makes daily life harder too when you can't speak. Gonna be working on some more probably firewall forward stuff today and some control stuff, just more of the same. Just little minutia, little details of everything that needs to get done as it's all coming together slowly. The fuselage I feel like is where the major visual progress really slows down. And it's just a bunch of details on the inside of the plane, on the engine and everything. Just gonna take it one step at a time and work through it today. I packed a lunch for myself and just kind of work through it until 2:30, 3 o'clock when I'll call it quits and head home. I've got to run an errand on the way home and then be back at it to work into the evening. So that's the plan for today. Made it to the Build Assist Center for week 5, day 2.
Brief rundown on flaring. So there's 2 different types of flares. They go by the degree. 45 degree, which is standard for automotive, HVAC, that sort of stuff.
Okay.
And then a 37 degree, which is common to aviation and a few other specialty industries, but aviation is 37 degree. So you couldn't just buy one of these at an automotive shop and use it. You got to make sure that it's a 37 degree flare. So you can fit these fittings. This is the flaring deck. So you can see it's adjustable for different types of tubing. So this refers to your outside diameter, correct.
OD.
So 5/16, 3/8, quarter, blah, 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 all the way up to 5/8. This is, essentially it's the flaring tool.
It's like a press.
It's a press, essentially, yeah, it's a press. There's a fancier name for it, but I can't remember what it is right now. But that more or less locks onto the deck.
And tube comes in from the other side?
Correct, and it'll get locked in there, and this is what's gonna create the flare, and it'll become apparent in a second. This right here is for deburring. It's a deburring tool. So we deburr both the inside and we can deburr the outside of the tube after we cut it. And these are the tube cutters. So the smaller tube cutter is typically used up to about 3/8, and it's used, you would use it if you have an internal thing like this and you need to cut it here. And the larger one won't work.
Got it.
Otherwise, you'd always sort of go with the larger one right here. This is also a spindle deburr.
Edge deburr.
Exactly, edge deburr, but I don't really use this one because I don't feel like it works that good. So the main things we're going to be using is the cutting tool, the deburring tool, and the flaring tool.
Okay.
And the last one is the bending tool. So this is a bending mandrel. It's good for 3 different sizes, quarter, 5/16, and 3/8. And it's a little bit tricky. I'll show you once we do some bends. You'll sort of get the hang of it, but you're going to lock it in, and then you will you'll register the bend degree that you want. Be a couple caveats, but essentially that's what's going to create the bends.
Cool.
We have a minimum that we can do, and the reason for that is because when you do your flaring, you obviously have to have your B-nut and your collar on first. And so it's really driven by the collar, because the collar won't move around a radius. So it kind of gets stuck there. So this is what drives your minimum. Once you have to have it in place, you're going to be flaring with that on like that.
Yeah.
And then you can see you're going to need about a dime to a pennyworth above the deck to give you the optimal flare. So you can cut that back a little bit, but that's about, to there is about the smallest you're ever going to get. And so that's why in there we don't have tighter radiuses around the pump, because it's kind of driven by that. And that's pretty much standard. On this diameter, you're just not going to get much tighter. You can get tighter radiuses on a smaller diameter pipe, but on the 3/8, that's about as tight as we get.
Cool.
All right.
All right.
So I'll just have you do a practice flare just on this. So the first thing we'll do is we'll mark where you're going to cut. So just make an arbitrary mark about maybe a 1/4 inch or so away from the end.
Okay.
Perfect. And now you're going to go ahead and cut. Have you used one of those cutters before?
I've used a pipe cutter and a filter cutter before.
It's very similar to that. Very similar. So you get it lined up in there. Exactly. And then you rotate around. And each time you go around, you just do a little more of a twist. There you go. Big mistake people always make is they just crank down first and
pucker it.
Yeah, exactly. Oblongate the hole. Perfect. There you go. All right, now you've made your cut. This particular aluminum is pretty soft. So the exterior deburr is not as necessary, but the interior is, because you
Yeah, I
got
see
the
it.
edge. Correct. So you can go and grab the interior deburr.
Okay.
And you just rotate that and then it'll slide out, and then you just tighten it up again. There
Ah,
you go.
okay.
Yep. And you just do a couple turns in there. And now you want to set that about, if you set a penny on the deck next to it, you want it about that high.
Okay.
And I'll
Right.
explain why that deck thing matters once you do your flare.
Okay.
Okay, so now that you've got that, you want to make sure it's got a good amount of tightness on it, otherwise it'll slip through there. Okay. And now you're going to fit this on, but before you do that, you're going to put just a drop of this on the very end of that.
Okay.
There you go. That should be fine.
That's it, all right.
Yeah, that's all you need. Just a little bit of a drop. Yep.
Okay.
And then, yep, you want to get it, and that'll rotate and kind of lock on. You may need to back out the plunger a little bit. I think it might be okay.
There it goes.
Yep. So now the 3 things to check, kind of get it at least so it seems like it's centered and it's ready, but don't clamp down it yet. Then you want to do a few checks. You first want to check to make sure this twisted and it's tight against there and on the other side, so that it's not loose. Yep. And the second thing is you want to make sure you're kind of centered in on there and not off to one side.
Yeah, looks
Yep.
good.
Okay, and if you feel good, and these are sitting square on there, which they are. Yep.
Okay.
Now you feel good, you just crank it down.
Okay.
Yeah, that looks good. Now you just back it out, and you won't have to go too far. It'll actually rotate off of there. There you go. Yep, and now you just loosen that up. Yep. One thing to be aware of is when you have it in there, sometimes people accidentally catch on this and they use this as a handle and they bend their pipe. So always be aware of that. If it's too hard to do, just lock this bit in the vise and then just undo it.
Got it.
Perfect. Okay, great. Now
Cool.
let's go ahead and slide the collar on there.
This way?
Exactly right.
Okay.
Yep. And now,
Oh, yeah.
so this is what we're aiming for here. If you see the outer edge of that collar,
Yes.
you're aiming for this should not be further than that.
I see.
And then if you look inside there, it's got a very slight, this one doesn't have too, a little bit of a chamfer in there.
Okay.
So you're looking at the exposed face, that ring of this thing. It shouldn't be any closer inside of that, and it shouldn't be out any further. So it needs to sit somewhere inside that ring right there that you're
Okay.
seeing. So this one's
And
right
that's
on
why
the outer
that
edge.
penny clearance
Correct.
is important.
Exactly.
Okay.
So
I
if you're
see.
too high, this thing will get really big, and if you're too low, it'll get really small in it. So this is almost spot on.
Okay,
And
cool.
now the other thing is, if you have it spot on, the other thing is your nut will slide on there really nice.
Got it.
The other thing you're looking for is you want to look across this and make sure it all looks pretty symmetrical. Like if this was really small here and really tall here, that and it was off that way, it'd be problematic. If you had some deep scoring or anything going on in here, that would be pretty bad. But that surface looks pretty good.
Okay.
So I'd say this is a viable flare.
Cool.
Okay. We're gonna do a couple different pieces. The first piece is pretty straightforward. We're just gonna do that U-bend. And,
Okay.
it's straightforward because I know exactly what we need to cut, and I know exactly where we need to put on here to make the bend
Yeah.
so that it'll fit that radius.
Cool.
Put your end through, this is the 3/8 mandrel. Yep. And then you wanna align the edge of the pipe with this face here. So
Okay.
just pull it all the way through and align it. There
Oh,
go.
oh, you mean the
yeah,
end,
that
okay.
face, yep. So align that face.
Okay.
And then you'll need to swing this down until it makes contact, but don't bend any further. Just get it set in there straight. So if you're ready to go, you're just gonna bend it down.
Okay. And then do I need to hang on to the pipe or?
Nope, it'll
Okay.
hold itself, yeah. It'll
Okay.
keep itself in there with friction.
Give it just another tiny squeeze.
Cool. All right.
Yeah, that looks better.
Yep, and now we'll do the same thing with the other side.
Okay, so
And we're
again
gonna
to
align
the
it.
edge.
Correct, yeah. And that's
Okay.
why I do the 6.3, because I know if you align it with both those edges, you're gonna get right on the
Got it,
money
got
for
it.
this. It's about 2.7 inches center to center.
Okay, and I'm lining this up with
Correct, exactly right.
the mandrel. Okay.
You got it.
Yeah. Okay.
All right, so now, remember what I was saying about the minimum you'll be able to get off these guys?
Yes.
We want to get this as close as we can. And they should be about the same. They should leave about the same if you've bent it consistently, but it's good to check.
Okay.
And then you want to just hold that there and you want to mark. So I usually take and I just put a mark. And then same here, I'll let you do that one so
Okay.
you get the feel of it. There you go.
And you're marking right at the deck, right?
Yeah, and so, yeah, exactly. Make sure that's closed and make sure that the collar's up on it, but not in it. And you're marking just above the deck. You're marking about a penny's worth, so it's where you're gonna cut. The idea is that when you go to flare it, you're gonna need to be able to get that tool on there. And that's why you're checking it now. Because if you were to cut any less, then you won't have enough sticking out to do the flare once
Gotcha.
the collar's on. So that's
Gotcha,
the
gotcha.
point. So now this is, because that you have that internal one, this is where the little job comes in.
Cool.
You can swing that around inside itself. You'll just cut down those. It should cut roughly the same off as what you had there,
Okay.
give or take.
Is that right about where it needs to be on your mark?
Yep, looks good.
All right, back in the car, getting ready to head back to the house right at 3:30. A reasonably productive day today. I am definitely starting to lose my voice. Got a few firewall forward things done, like mounting the fuel filter, mounting the gascolator, and then pretty much spent the last couple of hours working on the hard lines for the fuel pump assembly, which is basically 2 inline fuel pumps with bypass lines that have check valves in them so the fuel can't go the other way. Casey walked me through how to bend the tubes and flare them. Of course, make sure you put the bittings on before you flare the end of it. Kind of bummed Chelsea wasn't here for all of that, because I know that's stuff that she's done before, she has experience doing. That was satisfying to see the fuel pump assembly kind of come together. Everything's dry fitted, everything fits perfectly. We're ready to put it together with sealant, thread locker. Casey's gonna walk us through that. Tomorrow, then we're gonna actually hook up some electrical connections to the pumps. That will eventually get hooked into the switches that are in the cockpit to control the individual fuel pumps. And then that guy will be ready to go on the firewall. And I think that was kind of like the bigger assembly that I was thinking about going on the firewall. The rest of the stuff I feel like is gonna be on the engine mainly. It's gonna be exhaust stuff, it's gonna be electrical stuff, accessories. Got all of that finished up. It's a warm, sunny afternoon. I'm gonna run an errand on the way back to the house. And when I get there, probably go on a long walk with Chelsea and Millie. We'll have some dinner. I'll dump all of this footage onto the computer, take care of some work on the computer into the evening, and then we'll be back at it tomorrow right here at the hangar. This is the conclusion of week 5, day 2 here at the airplane factory right across the taxiway from Sling Pilot Academy. We'll see you in the morning. All right, good morning, good morning. It is Wednesday morning, about 9:35, and we just hashed out a plan with Casey here on what we're gonna work on today. Chelsea's here today, by the way, so she's gonna be doing some more stuff. So these are just the normal fuel pumps that are gonna be mounted on the firewall. Fuel pump 1, fuel pump 2, these are bypass lines with check valves so that fuel can't flow the other direction. So that if either one of these pumps fail to the point where they are actually not letting fuel freely flow through it, the fuel will take the path of least resistance, go through these bypass lines through the check valve, and then it'll be good. The system will keep running. So these are redundant fuel pumps, and they're gonna go on the firewall right up there behind the Rotax. So what I'm gonna start working on probably right now, I'm gonna go ahead and mount this guy onto the firewall. I already have the rubber grommets in the firewall. I did that yesterday. After that, we're gonna cut some holes in the insulation to mount the bulkhead and fittings that are gonna be the supply and the return fuel lines coming through the firewall. We're gonna kind of work on some of that stuff today. I think at least the first half of today is really gonna be about the fuel system. So that's what we're gonna start tackling right now, starting with getting this guy done with its final assembly and all the sealing.
So the way this goes on is it has these screws that go all the way through the bracket, the mounting bracket that holds the assembly. And then we put a flat washer, and then this is a little spacer. And this is actually what goes through the firewall that will be between the interior and exterior surface. And the firewall has a little rubber grommet that this spacer will ride in. And then on the other side, it's gonna get the opposite or reverse order. So it will receive another flat washer, and then Josh has a lock nut that will go on it. Pretty simple.
Finally get it through.
Yeah, it only took us 3 step bits, 2 files, all to find out it was the wrong size. So we had to up it one more, up the ante. And now it fits perfectly. I think we used half a bottle of this cutting solution with the drill bit, the Dole drill bits, but it all worked out. We're making progress slowly but surely. Okay, so Josh did this yesterday when I wasn't here, so I missed all of the fun of that. I have not cut, deburred, flared, or bent rigid tubing. There's a combination of rigid and flexible lines on every single aircraft, and I have not fabricated rigid tubes. I've fabricated some hydraulic flexible hoses, but not rigid tubing since A&P school, which was 10 years ago.
So what we'll do is we'll get a minimum bend on that, and then we'll leave it and we'll kind of finesse it, because I think that the bend's gonna put us something weird, so we'll have to just change the bend. But we'll do a 90 to start, and we'll get it as tight as we can. We'll start with that. Let's just cut it at 12. That'll give us some room to play. Wow, that was impressive.
No, whatever.
We have here a professional. She was one with the material.
It's really important to clean out fuel lines after you're done fabricating them, whether they're flex hoses or rigid lines or whatever they are. Debris can be devastating.
There we go. You just clock that baby in there. You can do the honors. That's always a satisfying thing when you bring that V-nut in there.
Fits perfectly.
Yeah, when it just goes on.
So nice.
Beautiful thing.
All right, we're wrapping up the day here, but Heinrich from Plane Cool, that's his company. He actually designed and outfitted the demo TSi that we took to Canada and back with the air conditioning system that's on it. And there's a generator system that he's gonna help us outfit on this airplane that's kind of like we're gonna be kind of beta testers, but it's on the demo plane and we flew to Canada and back with it. It's great. And it's super small and compact, and this is the voltage regulator for it. So it's a DC generator. So there's no need for like, there's no elaborate electronics that go with it. It does a lot of stuff internally, and then this is the voltage regulator for it. And we're thinking that we're gonna mount this right here on the front of the battery box, and we're gonna make like a hat shelf kind of thing to stand it off so that we can get fasteners in there and mount it to the battery box. So we think it's gonna live right there. And then the generator itself, it's like maybe a little bit bigger than a Coke can, or like we have these little coffee Yetis that are about that big. That's about how big it's gonna be, and it's gonna go right over here on the outboard side of the motor mounts. And Heinrich was just explaining this to me, and he actually showed me the CAD drawings, and it looks great. So there's a fitting for a pulley on the rear end of the crankshaft right in there. It's real hard to see from this perspective, but there's gonna be a pulley right there, and then there's gonna be brackets mounted to the white motor mount. Yeah, you can see that little pulley mount right there. A pulley will be spinning with the crankshaft on the back of that. And the generator will be mounted outboard right here, where you can clearly see it on the side of the engine, clearly inspect it, and the belt is gonna go between the engine's mounts and then the motor mounts that are on the airframe. The belt's gonna go right through there. And he said he worked out a way such that the pulley that's being utilized by the generator is also the tensioner pulley, which is just a great way to keep it compact. And then the wiring will just go right up here to the voltage regulator for the generator system, and then it'll feed right into our bus and provide an additional 30 amps of charging power to our battery, which will be right here. So starting to work out these early decisions with the electrical stuff, but this will be our voltage regulator for that generator system. This isn't gonna be totally the Wild West. We're not shooting in the dark here. It's not like this system has never been used. It's used on a lot of airplanes out there in the experimental world. We're just gonna be one of the first to have it on a Sling TSi. It's gonna be great, a great compact modern system right over here to help charge our electronics.
We are badging in for week 5, day 4. It's Thursday morning, and we made some good progress yesterday. I will say that there are still some unknowns with this build, some little things that the experimental world of aviation is gonna allow us to be the executive decision makers on. We have been so involved with it up to this point, and I still feel like there are a lot of decisions to make, and we have been loving every single second of this process, even the more frustrating tasks. So we're so grateful for the time that we've already had out here, and we're looking forward to coming back, even though we haven't even left yet.
Yeah, that's good. All right, check valve is installed. All right, this is the last fuel line I have created. So it's gonna go right there. Okay, get that guy snugged down. So that is where that's gonna be. This can kind of move around a little bit to where we're gonna find is the best spot. but right there is pretty good. So that fits, that fits. This guy fit nicely. So fuel comes from the fuel selector through the firewall right here, comes down this tube into the gascolator. So this is where you actually will do your pre-flight thing. Down here where my hand is, at the bottom of this is where you put the sump cup in and drain fuel out of the gascolator. Fuel goes through there, comes out right here, goes up this tube that I just made into fuel pump 1, and then there's a bypass line in case this fails. And then it comes around, makes a 180-degree bend, and comes into fuel pump 2. Again, a bypass line there in case this fails. And then it comes down and around up into the fuel filter with a bypass line with a check valve in case the fuel filter fails, and then out to the engine from there. So all the hard fuel lines on the firewall are complete. Now we have to take all of it apart, and we're gonna take this whole assembly off, take the pumps off, and we're gonna do a little bit of work to this guy.
With the fuel hard lines almost complete, Chelsea started some work on the oil hoses for the Rotax 916's dry sump oil system. We wrapped up for the day and promptly returned the following morning to close out the week. And first thing on this Friday morning, I was notified that our interior has arrived from Africa. So I went to the hangar next door to take a look.
Looks great. Are those floor panels? Rudder pedal carpet, okay. Awesome. Good morning, good morning. It's week 5, day 5. It's Friday morning. Chelsea's on the computer in the car. She's gonna come in here in just a little bit. She's just in a distraction-free environment, getting a couple things done. Yesterday, I finished up all the hard lines for the fuel system on the firewall, and Chelsea started working on all the oil lines. That was a bit of a cumbersome process because it just takes a lot of force to push them in, and frankly, she's a small person. For anybody, that's kind of a hard, kind of task. All of the hard fuel lines for the fuel pump, fuel filter, and gascolator system are right here. These are all gonna get mounted to the firewall. I bent and measured all of the stuff, cut it and flared everything, luckily with no major mistakes, so I was happy about that. Here are the fuel pumps, fuel pump 1 and 2. Casey fastened the wires onto them this morning. Beyond that, we put some fiberglass fire shield on these brackets where the fuel pumps are actually going to be cradled, just to add a little extra padding for them so that it's not metal on metal. There's kind of like a soft, looks like aluminum foil, but it's a little heat shield sort of thing. And then there's fiberglass underneath that. Today also is the opening day of the May 2025 class here at Sling Pilot Academy, and actually right across the taxiway, they're doing their whole orientation and everything. And Chelsea and I are actually gonna speak at it at, I believe, 12:45. We're gonna hop up on stage and just say a few words about flight training and flying, and of course, the content that we make and the mission behind it, and ultimately just wish the class good luck and safe flying through their training journey here at Sling Pilot Academy and beyond in their flying careers. So that's super cool. Lots of brand new students over there at the Pilot Academy. So I'm gonna go ahead and get started on this fuel pump assembly, start getting this all assembled, and hopefully this will be on the firewall and pretty much done before lunch. I might have to eat my words, that might not happen, but we'll see. That's the goal for right now.
This marks the end of week 5 of our Sling TSi build. And while there wasn't a ton of visual change, we've made a lot of progress on the little but important things. Being the first aircraft build for both Chelsea and I, it's so nice to have the opportunity to build our Sling TSi alongside a team who knows exactly what to do, when to do it, and walk us through each step of the process. It reduces the stress to a point where we can immerse ourselves in and enjoy this exciting process. In the next video, we're wrapping up our first 6-week stay here at the airplane factory, which will include making the battery cables, fuel and coolant hoses, camera power supply wiring, and mounting the wings and empennage to trim and fit the wing root and tail fairings onto our Sling TSi. We'll then top the week off with some familiarization flights in Sling Pilot Academy's Sling 2s before we start the long trip home. All of that will be in the next build video. Be sure to give this video a like if you did, subscribe if you haven't, and ring that notification bell so you don't miss out on the week 6 build video. Until then, you know the drill. I want you to stay happy and healthy, stay current in your flying, but most importantly, stay proficient. We'll see you in the next build video right here on Aviation 101. Fly safe.